513,000. Okay, first thing we need to do is find the model for the number of married couples. Again, this is no different than asking us to find or to solve the differential equation. What we're given is, as in this problem, we're given the derivative and we're asked to go back to the function. We're given the derivative, we're asked to go back to the function. So let's look at part A here. Using the very same process we have been, we're going to take the indefinite integral of, and remember the parentheses are extremely important, otherwise we are writing the wrong equation, minus 44.72t, and actually this needs to be a positive. That was a typo on my end, plus 709.1, close parentheses, and we need our differential t. Again, when we solve this, we will have found the function of that tells us the number of married couples in terms of years. Okay, so we end up with, and we just have to go through this term by term, and this is going to be add 1 to the exponent. So add 1 to the exponent and divide by the new exponent. So minus 44.72 t squared divided by 2 plus 709.1 t to the first power divided by 1 plus c. So we end up with the function m of t equals, we're going to divide 1.218 by 3, and that is going to give us 0.406 t cubed. We need to divide by 2, so this will be 22.36 t plus 709, excuse me, this is t squared back here, plus 709 t plus c. Now we're going to use the information we're given, that when the input is 35, the output is 59,513. So m of 35 equals 59,513. And so that will be with our putting 35 into our existing problem. And we'll squeeze in the plus c. What we're actually trying to do here is to look for a value of c. Now, there's all kinds of ways you can use your inspires, and I trust that you're able to do that. And we'll just say c is equal to 44,678.3. So our function is m of t equals 0.406 t cubed minus 22.36 t squared plus 709.1 t plus 44,678.3. Now, if we test this out and we put 35 back into our equation, we would in fact come up with our value of 59,513. Okay, that's part A. And it says now use the model to predict the number of married couples in 2012. So in 2012, t then would be equal to 42 years, and again we're basing this on how many years since 1970, and so that's 42 years since 1970. So now we just need to use this, and we have m of 42 equals, and I'm just not going to go back and replace that. You can do that, put 42 in and cube it, put 42 in and square it, put 42 in, and we end up with an answer of 6,5 6,5,097,000 married couples. Now this may be changing. There was something in the paper just this morning that said that the number of married couples was actually going down. So we may have to revise that equation, and that derivative might have been correct back in 1970 to 2005, but as of from 2005 to 2010, we may have a different model to work with. Okay, so what we've done in this section is to look at the antiderivative and then find some values that or some problems that we need to use the antiderivative in order to find our original function that we are wanting to ask questions about, such as this one: how many married couples in 2012? Okay, your extra credit Thanksgiving extra credit is in Blackboard, and if you, I'm going to send you first to the assignment portion of that, and you can take a look at that. We will continue with lecture, getting into the next section, and that section is an extra. It's not necessarily in your book, but I want to present it to you as a basis for why we are doing this work. So we'll pick up the lecture in the problem called Chapter 5 Extra.